Welcome to the channel. Today we will learn about binary search, one of the fastest searching algorithm. I will show you step by step how it works and how to implement it in C++. Whether you are preparing for interviews or building your skills, this video will make you binary search very easy to understand with you. So let's begin. So what is binary search? So before learning binary search, you have to compare between two different algorithms of searching in an array. First one is linear search, another is binary search. So let's begin. What is linear search? So in this algorithm, basically your task is to search the element linearly. So if 1 2 3 4 and 5 and then 6 you have given, and if your target, let's say, is 5, so what is the approach to find this fifth element, or the fifth element which is present or not? Your basically your approach should be like, is this element is present equal to 5? If this 2 is equal to 5, if this 3 is equal to 5, if this 4 is equal to 5, if this 5 is equal to 5. So you are traversing the whole array and checking with each element which is present in that array, and you are basically traversing and you are checking each element one by one, that is this element is present or not. So first I will write code for this linear search, then I will explain what is binary search and what is the how this complexity is O of n. I will explain it to you also. So let's start. Include IO stream. We are including input output files using namespace. I will make another video for just explaining this line, why I'm using namespace std. So what are these standard classes? I will explain. Okay. So the first approach is linear search. So here you have given an array. Let's say the array is 1 2 3 4 and 5, and your target is equal to, let's say, 3. Is 3 present in that array or not? And the size of the array is equal to 5, and you are making a function linear search, and you have to pass the array, its size, and the target. Okay, so let's make this function. I'm making a non-void function which is int. Okay, and it will return the index if the it will return the target's index. Okay, so int arr, int size, int target. Okay, so you have to just traverse the whole array and you are checking each element. So that's the reason you're using for loop for that. If the element is present, and why I'm using AR of mid. Okay. So if this AR of I, then if this is equivalent or equal to target, then I have to just return the index, return I. That's it. And if this target is not equal to this AR of I, then I have to return -1. So this int function will return something. So I have to store this return in a variable. So I have to just print the return value from that function. Okay, so it is equal to 2. So is it true or not? So my target is 3, and it is present at the second index. How? 0th index, first index, and second index. So it is perfectly fine. If I'm giving the index is equal to 5, then it will return 4. Yeah, it is perfectly working. So someone will ask you about the complexity, what complexity this code is being using. So you are using a for loop. So this for loop will basically take O of n complexity, and this return -1 will take O of 1. So overall the complexity for this algorithm will be O of n. So we have a better approach to solve this problem of searching. So let's start. The another approach to solve a problem is binary search. So binary search is an algorithm, and in this algorithm I will, you have some condition that has to be there, then you should apply. First is that the array should be sorted. Okay, so either it is in increasing or in decreasing, it has to be sorted. So your approach is that you have to divide the search space into half each iteration. Okay, so what is this? I will explain it when I will solve this problem. And the complexity should be less than the linear complexity. What was the linear complexity? It was O of n, so it is lesser than that, which is O of log n. So this is the code snippet which has been written over there. I will write the code, but I will explain why this is and how this is happening. You have to just take care that the given data or the given array should be what? Monotonic, either increasing way or in decreasing. Okay, so let's start. So this is the array which has been given to you, and it is in increasing order, so that's why you can use binary search algorithm. So let the size of the array is equal to 5 and the target is equal to, let's say, 4, or okay, and I'm making a function binary search. Okay, I'm passing the array, I'm passing the size of the array, and I'm passing the target. Okay, so I'm making this function. So I'm making a int function for that, and I'm passing the array, I'm passing the size of the array, and I'm passing the target. So this is the array, and I will make sure that you will be getting, so this is the array. Okay, so I have to make 3 variables first. So what are these variables? First variable is start. I'm initializing with 0. Why 0? Because this start will pointing to the first element of this array, which is equal to 1. I'm making another variable, as you understand, which is pointing to the last element of that array, which is equal to 5, because the size is equal to 5 and 5 minus 1 is equal to 4. So then it is pointing to the 4th index of this array. Okay, and I have another variable which is mid, which is equals to start plus end divided by 2, and I have to make this parenthesis bracket over there. Okay, so this is how the whole code will be working. We have 3 variables: start, end, and mid. Start is pointing to the first element of the array, mid is pointing to, end is pointing to the last element of the array, and mid is pointing to the middle value of the array, which is equals to here 3. Okay, so the same concept of 2-pointer approach, the start should be less than equal to end, and then you have to check for the, if the ARR of mid is equal to the target or not. If it is present, then you have to just return the mid value. It will return the mid index. Okay, so let me check and let me dry run this part so that you can understand. So what will be the ARR of mid? So ARR of mid should be equals to this value. So is this value is equal to target? So what is the target? I have set this target to 4. So is 3 is equal to 4? No, it is not. So what are the 2 possible cases that can be made from this? So else if ARR of mid is less than the target, or else if ARR of mid is greater than the target. These are the 2 possibilities that can be found. So what should be our approach? If this possible and else this possible. Okay, else if we have 2 else if conditions. Okay, so if ARR of mid, what is ARR of mid? ARR of mid is equal to 3. Is 3 less than equal to 4, it is true. So it is falling under this condition. So I have to find in this part of the array. So basically in this case we are basically splitting the array into two halves, and in this case I will be searching in this part. So the start variable, which was initially pointing to 1, will be moving to 3. So how we can make it? So the start should be equals to mid plus 1. So now what was the mid? Mid was this. So now the start will pointing to the 4, because 4, because mid plus 1, mid is equal to 3, this, and now it is pointing to this fourth element. Okay, and else if this mid is greater, error of mid is greater than the target, then you have to move the end pointer to mid minus 1. So just you have to try run on your copy, you will on your notebook, then you can easily find why I'm using this. And you have to just update this mid variable also. Let's say you can update here, and if you basically return this mid, if this element, if the target is not present in the whole array, then what you can do, just return minus 1. That it basically tells you this element is not present in the array. So let's execute. So if it is returning some integer value, then I have to store the integer value, okay, in an answer variable. Then I have to just print it out. So binary search algorithm, element is present at index number 3. So is 4 is present at index number 3? 0, 1, 2, 3. So yes, it is present at index number 3. Let me check for another example. Let's say the target, if I am sending is 1, then it will return 0. So yes, it is. And if I am sending a target which is not present in the whole array, let's say 14, which is not present in the whole array, then it will return minus 1. Why it is giving some error? Okay, yeah, it is basically giving the answer minus 1, because 14 is not present in the array. Okay, so let's move forward. If we have another problem, so these are the problem which has been asked in interviews. Okay, so find the first occurrence. So first I will explain this question to you, then I will basically, these are all questions based on binary search. So let's understand the question first, then make some intuition that how we can solve that problem. So let the array is equal to 1, 2, 3, 3, 3, 3, 4 and 5, let's say, and let the size of the array, which is equal to what it is, it should be, I think, 9. Okay, and let's say the target is equal to 3. So my job or my task is to find where was the first occurrence of the 3. So it is present at first time, it occur at index number 2, 0, 1 and then 2. So I have to return 2 for this target value. Okay, so your target is to find the first occurrence. So I have to make a function for that, and the name should be very relevant in this case. So finding first index, and I have to send the array, then I have to send the size of the array, and then I have to send the target. Okay, got it. So let's make here, I'm making int return type function, and then in size, in target, and I'm basically doing the what I have to do here. I'm using the concept of binary search to solve this problem, so that's why I'm using this code. Okay, I'm copying and then I'm pasting this code, same code. Okay, so in this case, what I have to do, this is our test case. Okay, I'm just taking it here, I'm copying. Okay, this is our test case. I have to find where the first time of occurrence of this number, which is 3. So first my start should be pointing to 0, that's totally fine, and the end should be pointing to the last element, which is equal to 3, and the mid is equal to start plus end, which is 0 plus 8 by 2, which is equal to 4. So 0, 1, 2, 3 and 4. So this is present, yes. So it will return, I think, 0, 1, 2, 3 and 4. It will return 4. So let's execute this code, print answer, and just print out the answer. And this answer is 4, but it is wrong. Why wrong? Because the correct answer should be 2, because the first occurrence of 3 is 2. So how we can make it? So first I have to, if we find that if the ARR of mid is equal to the target, then I have to store the result, and basically we have to move in left side of the array. So how we can make? First I have to make a variable. I will explain this. I will try run this again. So if this happen, then you have to store the array, store the mid value into this array, and just you have to move to left side of the array, left side of the array. So how you can do it? Just by using end is equal to mid minus 1. Okay, and just you don't have to return -1, you have to just return answer. Let me check it is working or not. The answer should be equals to 2. Yeah, it is working fine, and I will explain this whole code again. Okay, so what I am doing here, so basically I am creating another variable for storing the first index of this array. So my task is to store the first index. Okay, so this, if it is not being present in that array, then it will return -1. So if this case is happening, that if the ARR of mid is equal to target, then I have to store the target value into this answer variable, and I'm just moving to left side because I know that this is the target, and there is a chances that this can also be found in the left side of the array. So that's the reason I'm using, and I'm going backward, or I'm going to left side of the array. So that's why I'm using this end variable equal to mid -1. So that's how the whole code is working, and this is the same code I'm using. So that's how the whole code is working. So I think I'm able to explain it to you. So let's move to the another problem, which is the last occurrence. Exactly the same problem. You have to just copy paste this same code and just rename the function to the last. Okay, so just copying and just pasting this code and making it first, finding last. Okay, so what you have to do is you have to just move to right side. Just how do you do this? Start should be equal to mid +1. Just it will basically return the last element. Okay, so what should be the last index of 3 which is present in that array, which is 0, 1, 2, 3, 4, 5 and 6. Then answer should be equals to 6. So is it working or not? So it is not working for some reasons. Okay, so let me check. Yes, it is perfectly fine. which is equals to 6. So I will explain this code again. So in this case, if I found that the ARR of mid is equal to the target, then I know that it must be the answer, but there is a chances that answer may be found in right side, because I have to find the last occurrence of that element. So it must be present in right. If it is present in right, then I have to move our start pointer to mid plus 1. So if if and these two cases are the same, so that's why I'm going to right part of that array. So this is how, and finally I have to return the answer. So if there is another problem, then I will explain it to you. Find the total occurrence. Okay, so basically I have to find the total occurrence. Okay, so how many threes are in this array? So this is your task. So 1, 2, 3, 4 and 5. So you have to return 5. Okay, so you have to make a function which will return. Okay, so you have to just find something that, okay, find total occurrence. Okay, so let the I'm creating a void function for that, and the name of the function should be total occurrence, and I'm sending the ARR of the array, the size and the target. And basically my task is, I'm using these two functions. Okay, so the first function is this, so it will return something, then I have to store it into a variable. This is the first index where it is present, which should be equals to this, and I'm sending that ARR size and ARR of target into this, and the last index should be equals to this function. It will return me. Okay, and the total occurrence should be equals to last minus first. That's it. Last index minus first minus 1. Okay, that's it. So let's print. It will return, or it will give output of what? 1, 2, 3, 4 and 5. Okay, so let's execute. The total occurrence of 3 is 3, 0, 1, 2 and 3. Okay, so okay, no, plus 1. Okay, why I'm doing, yeah, just you should do some maths, then you can easily find why I'm doing all those stuffs. So the answer is 5. So is it true or not? So total number of threes are 5. So 1, 2, 3, 4 and 5. It is perfectly fine. If I'm changing from 3 to another 3, and this size should be equals to 10, then the answer should be equals to 6. Is it working fine or not? Yes, it is. So the first you have to find for total occurrence, so you have to find the last index and then minus with first index, and then you have to add with plus 1 to find the total occurrence of that element. So that's how you can calculate the total occurrence. So this is a very simple function. Let me check we have another problem or not. So let's compare with two binary searches or linear searches. So which is better complexity? So obviously this binary search has less complexity as compared to the linear search, because it has O of log n and data set requirement. Linear search can be done on unsorted array, but for binary search there is a condition that the Array or list should be sorted, and linear search is generally applied for small data, and for binary search you can apply it on two data. First one should be sorted, that has to be sorted, and it is basically widely used for large data sets. Conclusion. So you have to I have explained each and every part of binary search or linear search, so you have to solve as many problems so that it can be more good for you for your interview. So thanks for watching this video, guys. Till then, goodbye.